part B of lesson 1-4 is on average rates of change. So an average rate of change, in algebra you learn that the slope between any 2 points on the graph of a linear function represents a constant rate of change. For a nonlinear function, the slope changes between different pairs of points. So we can only talk about the average rate of change between any 2 points. So as an example, you see here, we've got a curve, the blue curve, and if you pick 2 particular points, like you can see, we can come up with an average rate of change. And you can see on this particular example, it produces a secant line, and then the slope of that secant line represents the average rate of change. So hopefully you remember how to find slopes. If not, here's a slope formula. You have the change of y divided by the change of x. Now if we pick 2 different points, like let me use a yellow point here. If I pick this particular point here and this point here, then our average rate of change would be a positive slope and a positive rate of change. So sometimes it's negative and sometimes it's positive. So here's the kind of problems you're going to be doing. You're going to be given a function like this right here, f of x equals negative x to the third plus 3x. If you wanted to graph that, you could do that. You can see the blue graph on the left. And you're going to be asked to find the average rate of change, part A, from negative 2 to negative 1. So if you plot the coordinate point at negative 2 right here, and at negative 1 right here, and then draw a line between those 2 points, you can see that's producing a negative slope. So here's how we'd find the average rate of change for this function between negative 2 and negative 1. We put negative 2 into the function, and that would give us let's see here. That's going to give me negative 8, making it positive 8 minus 6. So f of negative 2 is 2. Then we put the other value, negative 1, in to the function, and that would give us let's see here, we're going to get 1 minus 3, which is negative 2. So now that we know the outputs, and again the outputs are right here. One second. There we go. The outputs are right here. Then we just use the slope formula. So our slope would be the change of y, 2 minus a negative 2, divided by the change of x, negative 2 minus a negative 1. This would give us a slope of 4 over negative 1, which is negative 4. And so then does the slope of this red line that we're seeing here, does it appear to be negative 4? To me it does. Let's do another example. Same function. This time it's from 0 to 1. So if you plot a point at x equals 0 right here, and another point at x equals 1 right here, and draw a line between them, you're going to see a positive slope. So to find the average rate of change, you have to plug 0 into this function. And putting 0 into this function would give us 0. And we also need to put 1 into this function. And if we put 1 into this function, we would get 2. And so now we have to use these 2 outputs. Again, these are the 2 outputs with the given inputs. And so now to find the slope, take the change of y, 2 minus 0, over the change of x, 1 minus 0, and that's going to give us 2. So our average rate of change is 2. Let's just do one more example. This particular function is a third-degree polynomial function. I do not have a picture of the graph. It says find the average rate of change between 2 and 3. So we have to find the output when the input is 2. And so that's going to give me, let's see here, -4. We also need to find the output when the input is 3. And so that's going to give us I think 2. And so now that we have the 2 outputs, now we can find our slope, which is change of y divided by change of x. And that would give us 6/1. So our average rate of change is